we are decarbonizing our electrical grid much faster as compared to any other industries. And there are many projections out there. If we consider this particular projection here, so we can say that, and we are going to apply this carbon capture technologies in next 30 years. So we can see that the scope 1 and scope 2 emissions is reduced by about almost about 10%. So now let's look into the future operation when we are going to implement the carbon capture. So if we talk about the fuel firing, so it will remain the same as we have seen in the before the applying the carbon capture. Now we can see that because we have in pre-investment level 1, we have already taken care of the dual drives in the compressors. So we could able to reduce our steam import. So here we can see that the steam import is reduced. But in the LEAP case, since our steam generation is also reduced, so we can see that the steam import in LEAP 2 is going to be slightly higher as compared to the level 1 investment. Similarly, so compression electrification is required for the LEAP 1, and we need a more electrification for LEAP 2. So electrical consumption would be in the line of what we have seen in the percentage of compression electrified. So when we combine the scope 1 and scope 2 emissions, so we can see that level 1 pre-investment is going to have a least emission as compared to the others. Now let's talk about the extra investment, which is at year 0. Year 0 when our plant is built. So here we are going to consider the cost for the heater pre-investment, the cost differential of the level 2 heaters, which is relative to level 0, and the cost differentials of the compressor drive. So if we see, so you can see the level 1 is going to be, you need a very minimal pre-investment required just to achieve, you can achieve your carbon capture in a future. So this can be easily achieved by pre-investing at the initial stage. Now we are going to discuss about the total investment for the year X. Year X, when you're when we are going to apply the carbon capture technology, implement the carbon capture technology. So here we will need the cost, the modifications that is required for the carbon capture, the cost for the carbon capture unit, and the cost differential of OPEX from year 0 to X related to 0. So if we see that, so the total investment for the LEAP case is reduced significantly as compared to the level 1 pre-investment. Now, if we talk about the OPEX also, so OPEX, which is when after implementing the carbon capture, so we are going to see the LEAP case is going to be the lowest OPEX because of the lower capacity of the carbon capture unit. So if we talk about the payback period, by considering that the LEAP is going to be applied sooner as compared to the
Gaurav.
level 1 pre-investment, just time to about 1 minute. So we can see that the LEAP has the lowest pre-investment, lowest payback period basically. So in conclusion, so we have given the many options here for the pre-investment. So just in conclusion, so level 0, no hope. That means there's no plan of carbon capture or any carbon incentives or mandates is going to be there in the duration of your plant life. When we talk about the level 1, that means future is uncertain. So we want to do something today, but we are not sure of the future. And if we are planning to pre-invest in we are planning to actually implement the carbon capture as a part of the expansion, then we can do this as a level 1 pre-investment as well. Level 2 pre-investment is best when we are planning to implement the carbon capture soon. And when the electricity is inexpensive, it's green and is incentivized. And similarly, if our target is to also minimize your captured carbon here. So with this, I end the session. Thank you so much for patience. Thank you.
Thank you, Gaurav. So we have seen the process side of the decarbonization and moving into petrochemicals. Now we will talk something about the catalyst advances. So our next speaker, Mr. Mukund Balachandran from GRACE, will be talking about new FCC catalyst technologies for increased petchem. Over to you, Mukund. So kindly keep the time at check.
Good morning, everyone. And on the onset, I would like to thank the organizers, the organizing committee of CHT, for giving us the opportunity to speak in this forum. And on behalf of Grace and the extended Grace family, it's indeed my pleasure to be here. I think, ma'am, you and sir did set the tone at the beginning of the session by saying that, the refining and the petrochemical business, it's very close to our heart, and it's now about 20 years, even for me to be, I've been working in FCC for such a long time, and I see all the experts here as the leaders. So from our side, we are going to talk about the catalyst advancements essentially, and in particular to the FCC side of the business, right, which has uh, now been about more than 80 years, and it's been the workhorse of the refinery or so, like I would like to say. And it's been asked to deliver across its time more and more value for the refiners, essentially driving the business. But that being said, uh, I'll be using certain slides, skipping a couple of because of the time constraints, but we'll be giving an extended version to the organizers after the session, and so that you can have that when it's uploaded into the system, right? Uh, we do see a growing demand, especially out of the existing refining assets, as well as any new projects that are being envisaged. And from our perspective, at least, we think that the FCC would be playing a major role for the years to come, specifically in driving towards more barrels of, let's say, ethylene, propylene, and butylenes as what is desired out of you from your perspective, essentially. We take propylene as kind of a benchmark and then weigh it against the other light olefins part of it. Uh, Depending on if you already have an asset, it's an easy revamp, it's an easy change to a workable catalyst solution. I mean, and it can produce that much more barrel of what you're essentially looking at. And looking at most of the projections and how we think the market may go to, so we are also working essentially from our side to ensure that you have the best product available that would encompass the requirement from your side as well, either through expansion or through the future of, let's say, the crude to chemicals kind of a project that can come. We do see that the FCC asset is going to play a very, very major role, at least for the next 20, 30 years, for at least for our, at least for my working life cycle, I guess. But we do see a lot of benefits and a lot of advantage in that. And we are also looking ahead, working with our customers, with our partners, uh, to ensure that you have what is best for your operating units, essentially. Right. So in the past, mostly, when we talk about FCC, it's generally the usual contaminants. It's usually nickel, it's usually vanadium. We know what to do, what not to do, etc. But like you also said, ma'am, it's more of it's evolving. There are more tougher feeds that are being processed, tougher. It's like a garbage dump, right? You put anything you want, and you're expected to make a product slate out of it, right? A few things we have noticed. I'll talk about one from the catalyst side, and the second from the ZSM side, because both work together to make that much more light olefins essentially out of the unit, and that can be used for the downstream processing entities, right? So essentially, we were looking at two or three things. One is how to better manage the usual metals, which is nickel, vanadium, and at the same time also look at the other part of it, which is uh, more prominent in certain areas of the globe, but it's also coming into India, which is like calcium, iron, etc. That is coming in. We had an excellent platform, and what we started to do was to think in terms of how the future would look like and how to start working on that, especially for better upgradation to make better precursors from the base catalyst side, so that the additive can work along with it to make essentially the product slate that you're looking for, be it propylene, be it ethylene, be it butylenes. That being said, it's always a 2-3 step process. You work internally, you do multiple R&D studies, you have your own benchmarks, and then you see where you are at in terms of selectivities, in terms of performance characteristics. So starting from a small bench scale ACE to pilot plant, etc. And then you find the right person, right customer to have the first logical trial and then the combined larger trial here. Uh, what we were looking essentially here is that a few things. One is, of course, coke selectivity. You don't want, you want as low as a delta coke as possible. Better retention in terms of activity, better bottom subgradation, and more gasoline octane. So this was the first case for essentially this product, and those were the key objectives that was given to us, essentially speaking. And we went over our own older platform, which a lot of you in India will know. We called it Genesis, and it was a really good benchmark catalyst, right? So step one, see, have the catalyst outperform the base, and then the step two comes in terms of the olefin production. Essentially, what we are seeing is we had a ECAT, we took it, we did our own studies, did our KBC modeling to ensure that everything lined up with what the refinery was seeing. So the targets that was given to us, we were able to move up in most of it. So more gasoline yields, stay within the LPG limit, etc. So this is part one. Have the catalyst work to improve the selectivities, and then comes the larger part of it, which is essentially, when you have a tougher feed processing, also ensure that you're not losing out on the dollars per barrel that you gain out of the FCC unit. Especially in this particular case, there was a large amount of iron that was coming into the system. And iron, unlike the other known metals, it kind of kills the catalyst essentially by covering up its surface, and you need to flush it out, and you need to have a better catalyst to absorb that metal. So that being said, step one was done, uh, and going larger into now comes the larger part. I would say, which is to drive up the olefins essentially, right? So ZSM5, you have the ZSM5 crystal. It works on the gasoline range olefins. You make ethylene, you make propylene. What we were also looking at essentially is that how best to drive deeper and deeper into the gasoline range olefins, so that you can get that much more C2 olefins, C3 olefins out of the existing asset, right? So the idea came of you need to keep the integrity of the product in terms of physical properties, etc., and at the same time, increase the relative activity of the entire crystal structure itself. So we had a benchmark additive which we called as olefin ultra MZ, and the next step, obvious step, was to have the crystal itself modified from our side. So that's what we are calling Zavanti. It's in Z for ZSM5. Avanti is Italian for looking forward, essentially. So somebody came up with a really nice name, I guess. But testing, we saw activity retention was better, and apple to apple, we were able to have a better improved activity essentially in the system. And when we went into the unit, essentially what we are seeing was that we were able to drive more and more propylene out of the unit, more and more ethylene out of the unit, depending on where you are at. So the relative activity can be optimized. If you need more ethylene, then there are an additional step that that we can do to get that. But if it's propylene, you want to limit overall ethylene production, that we can make those slight changes. But essentially speaking, it's more of a combination of how well your base catalyst is defined, how well the constraints and the objectives are defined, and how well the synergy works between the base catalyst and the olefin selective additive. There are a few case studies, resid, clean feed application, etc., but I'll not go too much into it. But proved multiple times, essentially over, and we are looking forward to have that product pretty soon, even into the Indian market, I guess. Uh, Essentially, that being said, so we have been in this business now for more than 80 years. The FCC unit has been in this in our life for more than 80 years, essentially. The larger idea, or the last point that I would like to leave the experts here is that we are here to stay. We are working on the new products and optimization of your overall business, essentially pertaining primarily to the FCC unit and along with our partners on the hydroprocessing side also. And we believe, at least from the region's perspective, that the refining future is bright, and the integration that we are looking at from not from our country, especially in the direction that is going, we have a lot of opportunities to optimize and to make and to derive the best product slate out of your existing asset that can be derived out of it, and we are more than happy to be here. So, as a parting comment, thank you for your time. Thank you for listening attentively. And we are at booth 21 and 24. We'll be happy to talk on a larger time frame there also. But thank you, ma'am.
Thank you, Mukund. Thank you. Now we have seen from process of cracker. Now we have seen the catalyst, how to maximize propylene. Now we'll hear what to do with propylene, one of the alternatives. So I request Mr. Manish Sarasat from Leondel Basel to talk about recent progress with metallocene polypropylene process technology. Over to you, Manish.
Thank you very much. So, thank you very much. Good morning. So, sorry, I will not be standing here because I have come all across to talk to you. So, I would like to talk to you straight, directly. So, and sir, I know you have kept a strong target, but as a chemist, we all know that if we are not giving the sufficient reaction time, reaction is not complete and the reaction is inefficient. But I will change the reaction kinetics to achieve your target. I will try to fulfill that.
Maybe you can start doing a better catalyst, using a better catalyst.
Yes, exactly. Ma'am, you are 100% right. And this is what I was thinking, which catalyst I can introduce to meet your target and to complete the reaction. And I will try to do that. So if you see this, sir has already set the target. And these slides will be having many information related to your products, a lot of information here. So before we move, please read this disclaimer. My lawyers love these disclaimers actually. Okay. So we as an organization, everyone know we are global leader. And we say it very humbly that we are global leader in polyolefin catalyst, in polyolefin process technologies, and in polyolefin production. And other than that, how many patents we have, which is written already here in this slide, what I would like to focus that we as an organization keep on changing with the need of society. So it means that we are equally considerate, not only for our business, but for the society. And this is what you can read in the slide, these bottom numbers, that how much money we are putting for the development of the society. So we are equally concerned for the society development as well as the business development. Now we focus on the hardcore. This is a technical session, and so I come from the Lyondell-Basel Technology Division, and in the Technology Division we have three sections: catalyst, technology licensing, and the technical services. This is our DNA. This is our DNA. So if you, we start from a Nobel Prize winning chemistry of Jiggler-Natta catalyst. From there, we keep on developing, keep on improving, introducing new technologies. So then this SDP process technology, then the PP process technology, and we never stopped. We kept on working continuously on further development.